All right, boys and girls, we're going to look at a way that you could possibly see a question on a test for prime and composite numbers, and that is using prime and composite numbers with models. And so they're a little bit different, but they're usually not too bad. And a lot of times I'll kind of relate these back to an array that you probably saw in third grade when you first started multiplying. And so there are four here. There are four different ones that we can look at on this page. I'm going to start with the one in the kind of top left corner. So I'll put a little check up there. So what they've done here is they've taken the number 8 and they have factored it, and they have shown all the different ways that the number 8 could look in an array, and to prove that since there are multiple ways it could look, it is still going to be considered a composite number because it has more than two factors. So again, if I'm just simply factoring, I'm thinking, well, there's 1 times 8, and there's also 2 times 4. And so when I look over at all the different options, it's kind of like, okay, well, I see a 1 by 8 array, or I see an 8 by 1 array, or a 4 by 2, or a 2 by 4. And so I'm seeing all the different ways that you could possibly see an array for the number 8. And a lot of times I'll tell my students that's kind of what you're looking for when you're checking out these models. You're kind of just seeing all the different ways one could look, and a lot of times it's just especially if it's going to be a prime number, a lot of times it'll just be what kind of looks like a straight line, because if it's a prime number, which we'll see on the second one with 3, if you were to factor 3 out, then really all you have is 1 times 3. But your arrays, and I'll kind of highlight them as I'm talking about, but your arrays are kind of just straight lines, because you're either going to have a 3 by 1, which you would see at the top, or you would have a 1 by 3. So they just kind of look like straight lines instead of having, more of a definite shape, like a shape of a square or a shape of a rectangle. And so, again, just some examples. The bottom left corner, put a little check down here. They're taking the number 6. So if you wanted to factor 6, you would say, okay, well, 1 times 6, but also 2 times 3. And so they drew out all the different ways. So you have a 6 by 1, you have a 1 by 6, you have a 3 by 2, and then you have a 2 by 3 array. And then the last one in the bottom right corner, you've got the number 5. 5 is a prime number, 1 times 5, and then that's it. So again, you're kind of seeing just a couple of straight lines. You're seeing a 5 by 1 or a 1 by 5. And so looking at all four here on this page, you can kind of see the difference between a composite, or the difference, the difference in a prime. And that would be, you definitely have more pictures for a composite number. You have more arrays, versus a prime number is not going to have as much. And so pretty simple here. This, you're kind of thinking about base 10 blocks on this example. I've seen them use base 10 blocks. I've seen them use symbols like hearts. I've seen them use numbers or letters. I've probably seen them use more numbers, more letters than anything. So I've seen them draw an array before, and they used a letter M, and they just used, I don't remember exactly what it was, but basically it was just an array that they were using the letter M for. So there are all kinds of different ways that you could see it. Most of the time, if you just wanted to keep it simple, you would still just count whatever it is, whatever the model is, you'd count it up, and then you'd ask yourself, okay, well, whatever that number is that a prime number or is that a composite number? And then you would use your skills in knowing, the difference between the two. All right, this particular page, I've put a couple examples here of some composite numbers. But what I thought I'd do is I would just make some quick sketches to show you the different ways that you can model these numbers. And so I'm going to start with 12. So obviously if you were to go and factor, it would be 1 times 12, be 2 times 6, and then 3 times 4, and then you would be finished. But if I wanted to make a model of that, or if I wanted to make some arrays for that, I would have to know how those would look. And so I'm going to start, and I'm just going to use an X for a symbol here. So I'm going to start with a pretty simple one. I'm going to start with a 4 by 3. So I'm going to draw 4 X's going across, and then I'm going to make 3 X's going down. And so I could represent that model there, that array, as a 4 by 3. I also could go for more of like a 3 by 4, which 3 could be going across, and then I have 4 going down. So that's just an example of what it could look like. I could go to my 2 by 6. So again, if I'm using X's here, maybe it's 2, and then I have 6 going down. And I'm kind of going sideways here just to make it fit, but I think you guys can get the idea of what I'm doing here. Or I could flip it, and I could do more of like a 6 by 2. So I could go 6 going across, and then just have basically 2 of those. And so again, kind of thinking about what it means in these pictures, what they could look like. I really think if you were to go back to when you were in 3rd grade and really think about arrays, that's what you're probably going to imagine here. I'm going to leave, because of space, I'm going to leave off the 1 by 12. But basically, a 1 by 12 will just kind of be a straight line. I'm going to come over to the 10. I'll do a couple here for 10. So I've got 1 times 10 is the obvious. And then we've got our math fact of 2 times 5. So I'll start this one with a 1 by 10. So I'm going to use X's again. So maybe it's just, basically a straight line of X's, but it's going to be a 1 by 10. So I have to think, all right, if it's a 1 by 10, 1 times 10 is 10, I have to have 10 X's. So I'm going to make sure I've got 1, 2, 3, 4, 5, 6, 7, 8. I need a couple more. All right, so I've got a 1 by 10 being represented there. Or I could go and I could basically lay it on its side. I could say, okay, well, let me have a 1 by 10 at the top, and basically have it going more horizontal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I'm just double checking, make sure I had 10 there. But that's kind of the idea that you get when you look at these models. If there was a model already made for you, I would just kind of stop and think, well, let me count it up. What do I see? What is it? And then whatever number that is, I could just justify whether it's prime or composite. So it really isn't too hard. A lot of times it still falls back on, do you understand what a prime number is? Do you understand what a composite number is? Because that's how I at least would teach it in my classes. If they're gonna give you an array, you're still probably gonna go and label it. And when you label it, in your mind, well, what do you have? What do you, what's in front of you? If you're looking at an array and you count it up and it's an array that makes 15, well, in your mind, you're thinking, okay, well, what do I know about 15? 15 is a composite number because of 1 times 15 and then 3 times 5. But if you're looking at an array of 7, then you might be thinking, okay, well, 7 is a prime number because it only has 2 factors, 1 times 7. So really not too bad. Really think about arrays. Really think about, again, your basic vocabulary. What do you know about prime and composite?